Now we will continue. That is, what are the preparation methods? Preparation of alkanes. There are various methods of the preparation methods. The first one is catalytic reduction of alkanes from unsaturated hydrocarbon. Catalytic reduction of either alkene or alkynes. Simply from alkenes or alkynes to prepare alkane. Okay, here now I am taking, this is one alkene. In this alkenes is reacted with hydrogen in the presence of nickel or platinum or palladium act as a catalyst to produce respective alkanes. Means this hydrogen added here on hydrogen, double bond can be converted into single bond or CH2R. Simply alkenes and alkynes on hydrogenation in the presence of finely divided catalysts like platinum or palladium, nickel or P2O2 also. Platinum dioxide act as a reducing agents like simply catalyst to produce alkane. If you take like that, now I am taking here alkyne. It is react with adding of hydrogen in the presence of nickel or platinum or palladium act as a catalyst to form a alkane. Simply from alkenes or alkynes, adding of hydrogen to the alkenes or alkynes in the presence of nickel or platinum, palladium or P2O2 act as a catalyst, then can be converted into alkane. Platinum and palladium can catalyze the reaction at room temperature, but nickel as a catalyst, certain temperature, higher temperature requires at higher temperature and high pressure. The catalyst nickel act as a catalyst, then the reactions are called Sabatier-Sanders reaction. Nickel act as a catalyst. It requires higher temperatures and pressure. Then the reactions are called Sabatier-Sanders reaction. Sabatier and Sanderson reaction. Methane cannot be prepared in this reaction because the reduction may also occur either platinum or palladium. The temperature either 150 to 250 degrees Celsius. Okay. This is the first one. Here the products are formed in the cis addition manner. Okay, hydrogen gas is absorbed on the surface of metal. Okay, how to formation of this one? So mechanism you can observe here. Mechanism. For example, if you take here mechanism. This is a homolytic cleavage of hydrogen in the presence of nickel act as a catalyst. Either 200 to 300 degrees Celsius. Here to form a hydrogen free radicals. Now I am taking here alkene. These hydrogen free radicals are connected with here one hydrogen. This bonding electron moving towards here. Here one more hydrogen atom. Simply this electron moving towards this addition is called cis addition. Here hydrogen gas is absorbed on the surface of metal where the reaction takes place, which results in the cis addition of hydrogen in product. It is an example of heterogeneous catalysis. Heterogeneous catalysis. But homogeneous catalysis may be occur in which the catalyst is present in the solution form, aqueous form. Okay, simply the catalysis is classified in two types: so homogeneous catalysis, heterogeneous catalysis. Okay, the catalysis in which both reactants and catalysts are in the same phase are called homogeneous catalysis. The catalysis in which both reactants and catalysts are in the different phase are called heterogeneous. Means it is a gaseous form, means it is a liquid form, or gaseous form, it is a solid form. Both are in the different states or different phases, then the catalysis is called homogeneous catalysis. Different means heterogeneous catalysis. If you take an example for homogeneous catalysis, now I am taking one example here, that is chlorotris triphenyl phosphine rhodium in benzene solvent. That is called example for homogeneous catalysis. For example, now I am taking here iso this is actual cyclopropane. This name is called vinyl cyclopropane. Vinyl cyclopropane. Now I am using here aqueous form of that is called homogeneous catalysis. H means rhodium, Cl, P, C6H5 taken thrice and also thrice. Okay, this catalyst name is called chlorotris triphenyl phosphine rhodium. This is example for homogeneous catalysis. Okay, then alkenes can be converted into alkane by adding of hydrogen. This is example for homogeneous catalysis. The specific catalyst, because a selective reduction may take place in this case. Okay, RHCl PC6H5 taken thrice and as well as taken thrice, then the catalyst is called Wilkinson's catalyst. What is the name of this one? Wilkinson's catalyst. Before I am using one catalyst P2O2, then the catalyst is called Adams catalyst. Okay, this is information about first preparation method of alkane. Second one is reduction of alkyl halide. Reduction of alkyl halide. It means here how when alkanes are prepared from alkynes by using of alkyl halide by using of reduction process. Reduction of alkyl halide. Already you know this is called alkane. It is treated with halogen. Removal of hydrogen is called alkyl. When a hydrogen atom is replaced by, when a halogen atom is attached to the alkane, that is called alkyl halide or halo alkane. Okay, in this alkyl halide, the reduction with either some reducing agents like simply, now I am taking here alkyl halides react with zinc copper couple to form a alkane. Okay, alkyl halide can be converted into alkane by using of zinc copper couple and as well as ethyl alcohol act as a catalyst. This is one. Or if you take one more here, alkyl halides can be converted into alkanes by using of either zinc plus acid, that is either acetic acid, zinc plus hydrochloric acid, or zinc plus sodium hydroxide. Okay, by using of these reagents, alkyl halide can be converted into alkanes. And primary, secondary alkyl halides are readily reduced to alkyl. These alkyl halides are classified into three types: one, primary alkyl halide, secondary alkyl halide, and tertiary alkyl halide. Okay, primary, secondary alkyl halides readily, these two, primary and secondary alcohol readily converted into alkane by using of lithium aluminum hydride act as a catalyst, but not secondary. Tertiary alkyl halide. Tertiary alkyl halides can be converted into alkenes, but not alkanes. Like that. Okay, by using of sodium borohydrates. Okay, one more reducing agent. Secondary alkyl halide, tertiary alkyl halides can be converted into alkane by using of sodium borohydrate, but not primary alkyl halide. In case triphenyl tin hydride, primary and secondary tertiary alkyl halides can be converted into alkane by using of triphenyl tin halide act as a reducing agent. And also iodides. Iodides may be reduced by heating with concentrated HI at 150 degrees Celsius. Reduction with HI usually carried out in the presence of small amount of red phosphorus. Simply alkyl halides, alkyl iodides react with hydrogen iodide. Alkyl iodide react with hydrogen iodide to form here in the presence of red phosphorus to form a alkane and as well as a iodine. Okay, in this combination of HI and red phosphorus, alcohols also can be converted into, is react with HI in the presence of red phosphorus. The temperature is here 150 degrees Celsius. 150 degrees Celsius. Then it be converted into alkanes RCH3 plus I2. In case if you take aldehyde also, RCHO is react with HI in the presence of red phosphorus on heating. Then it can be converted into, it is also can be converted into alkane plus water plus iodine gas. Here also water plus iodine gas. In case if you take carboxylic acid or ketones also, RCHO or COR, keto group, is react with HI in the presence of red phosphorus on heating to form plus H2O and also iodine. Like that, carboxylic acid also, RCOOH. RCOOH react with HI, the 6 moles of HI in the presence of red phosphorus on heating to form Here also same alkane RCH3 plus water plus I2. These are the preparation methods of from reduction of alkyl halide. And another one is hydrolysis of alkyl halide. Hydrolysis of alkyl halide. Okay, alkyl magnesium halide. Hydrolysis of alkyl magnesium halide. Third preparation method, hydrolysis of alkyl magnesium halide. Alkyl magnesium halide is also called Grignard reagent. Grignard reagent. So here you can observe that this alkyl halide combines with magnesium metal in the presence of dry ether to form alkyl magnesium halide. This magnesium halide react with water molecule to form two products, that is alkane plus magnesium hydroxide and as well as halide. It is treated with acid also, dilute hydrochloric acid, same products are obtained. Okay, what is the mechanism of this one? You can observe mechanism of this one, that is Grignard reagent mechanism. Alkyl magnesium halide, which can be dissociated into RMg plus X minus. This alkyl Mg plus again dissociate into R minus plus Mg plus 2. This R minus react with water molecule to form RH plus OH minus ions. Okay, these three products like Mg plus 2 plus X minus plus OH minus ions combine to form MgXOH. This is information about the third preparation, hydrolysis of alkyl magnesium halide. And fourth preparation is decarboxylation of fatty acids. Fourth one is another preparation method, decarboxylation of higher fatty acids. Simply, now I am taking fatty sodium or potassium salts of alkonoic acid heated with soda lime, RCOONA or K. Sodium or potassium salts of alkonoic acid is reacted with the soda lime. Soda lime means the mixture of sodium hydroxide and as well as the calcium oxide. Then the mixture is called soda lime to form alkane and as well as a sodium carbonate. Or if you take sodium ethanoate react with the soda lime, to form CH4 plus sodium carbonate. Yes, sodium propanoate to produce various products and also CH3, CH2 COONA react with soda lime to form ethane, methane plus hydrogen plus unsaturated hydrocarbon also. Various products are obtained. This is not useful general method for preparation. And fifth one is Wurtz reaction. Next one is Wurtz reaction. What is Wurtz reaction? Said that it is also one of the method to prepare alkanes. When alkyl halides react with the sodium metal in the presence of dry ether to form an alkane. For example, if you take methyl chloride, react with the sodium metal, 2 moles of methyl chloride in the presence of dry ether to form ethane, and 2 moles of sodium chloride. In case different alkyl halides, for example, now I am taking here methyl chloride is react with sodium metal. Here ethyl chloride I am taking in the presence of dry ether. Not only single product, there are various products are obtained. That is called crossed Wurtz reaction. Crossed Wurtz reaction. What are the product obtained here? There are 3 types of products are formed. That is called ethane, C2H6 ethane, C3H8 propane, C4H10 butane. 3 products are obtained. And finally, one more is there. In case one aliphatic alkyl halide, one aromatic alkyl halide, both are combined. For example, if you take here one aliphatic aromatic. For example, if you take here C6H5Cl react with sodium and also aliphatic CH3Cl in the presence of dry ether to form product here C6H5CH3 plus 2 NaCl. It is called toluene. Then the reaction is called Wurtz fitting reaction. Wurtz fitting reaction. This is information about Wurtz reaction. Wurtz reaction, crossed Wurtz and Wurtz fitting reaction. I hope it is clear. Still some more Now, what is the mechanism of Wurtz reaction, sir? Mechanism. 2 types of mechanisms are there. The first mechanism, now I am taking here ionic mechanism. Methyl chloride, methyl bromide or chloride react with sodium metal to form methyl sodium plus sodium bromide. In this methyl is again treated with methyl bromide to form ethane plus sodium bromide. This is one of the mechanism. This is simply ionic mechanism. Ionic reaction, ionic mechanism. And one more mechanism, free radical mechanism is there. Free radical mechanism. Free radical mechanism you can observe here by homolytic cleavage of methyl bromide to form a methyl free radical plus Br free radical. It is react with the sodium metal here, sodium metal to form a NaBr, Na plus Br. In this methyl free radical again combines with one more methyl free radical to form ethane. It is another mechanism. Two types of mechanisms are there. And another reaction is Franklin reaction. It is the Franklin reaction, sir. Okay, the reaction in which alkyl halides are react with the zinc metal in the presence of dry ether. Okay, the reaction which alkyl halides react with the sodium metal in the presence of dry ether is called Wurtz reaction. No? When alkyl halides are react with the zinc metal to produce in the presence of dry ether to form alkane is called Franklin reaction. Franklin reaction. Okay, like that. When alkyl halides react with lithium metal, that is called Core-House synthesis. One more reaction is Core-House synthesis. Core-House synthesis. Core-House synthesis. What is the Core-House synthesis, sir? When alkyl bromide react with lithium metal in the presence of dry ether to form methyl lithium plus lithium bromide. In this lithium bromide again combines with 2 moles of methyl bromide. React with copper iodide to form dimethyl lithium dimethyl cuprate. Lithium dimethyl cuprate and as well as a lithium iodide. This lithium iodide is react with ethyl bromide to form propane. CH3, CH2, CH3 plus methyl copper plus lithium bromide. Okay, then this catalyst is called, then the reagent is called Gilman's reagent. Okay, lithium dimethyl cuprate is also called Gilman's reagent. Gilman's reagent. It is also one of the preparation method of alkane. Still one more preparation method is that is called coal-based electrolysis method. It is also most important. Coal-based electrolysis method. Coal-based electrolysis method. Here, by the electrolysis of concentrated aqueous solution of alkali means sodium or potassium salts of saturated monocarboxylic acid using platinum electrode, alkanes can be prepared. That is simply RCOONA, sodium or potassium salts of higher fatty acids by passing of current to form alkane, carbon dioxide, sodium hydroxide and hydrogen gas is liberated. Then the reaction is called coal-based electrolysis. Here mechanism also is there. Okay, what is the mechanism of coal-based electrolysis? On passing of current to the RCOONA which can dissociate on passing of current to the sodium salts of higher fatty acids. Simply this one carboxylic acid which can dissociate into RCO minus and Na plus ions. At the cathode At cathode, reduction takes place. At cathode, sodium try to gain one electron to form sodium metal. This sodium metal react with water to form sodium hydroxide plus half H2. Half H2. Here reduction takes place. Gaining of electrons are called reduction takes place. Means at cathode, means these two are at cathode, sodium hydroxide and hydrogen gas is liberated. At anode carrying positive charge to gain to attract the negative charge species. Here what is the negative charge? RCO minus try to gain electrons to form alkane and as well as a carbon dioxide. That means here you can observe that try to losing of electrons here. Loss of 2 electrons to form RCOO free radicals. It can be converted into these RCOO. This is the mechanism. Some more preparation methods are there from Grignard reagents. Some Grignard reagent react with hydroacids, hydrohalogens like hydroacids or hydrohalogens. Okay, one more from Grignard reagent. From Grignard reagent by action of hydroacids like alkyl magnesium halide, hydroacids like water, alcohol and also phenols, C6H5OH. Alkyl halides react with water to form alkane and as well as a alkyl magnesium halohydroxide. In case of alkyl magnesium halide react with alcohol to form RCH3 plus MgXOH. Alkyl magnesium halide react with phenol, the presence of dry acid to form a RC6H5 Mg. It is also preparation methods. And how to prepare methane? Methane can be obtained by hydrolysis of methanes are prepared by hydrolysis of calcium, beryllium carbide and aluminum hydride. Methane obtained by how to prepare methane, sir? By the hydrolysis of beryllium carbide to form CH4 plus beryllium hydroxide. In case aluminum carbide hydrolysis of aluminum carbide to form methane and also aluminum hydroxide. H2. These are the preparation of methane gases of hydrolysis of beryllium carbide or hydrolysis of aluminum carbide. And finally, Wolff-Kishner reduction. Last preparation method is Wolff-Kishner reduction. What is Wolff-Kishner reduction, sir? Okay, Wolff-Kishner reduction, the carbonyl group of aldehyde or ketone converted into methylene on heating with hydrogen or semi-carbazone or azides in the presence of strong base. In the reduction is called Wolff-Kishner reduction. For example, now I am taking here either keto or alkane. Ketone, I am taking ketone here. It is reactive with hydrogen to form semi-carbazone like R, C, double bond, N, NH2. It is reactive with C2H5ONA or sodium hydroxide to form RCH2R plus nitrogen gas. In this nitrogen gas is liberated. That is called Wolff-Kishner reaction. Either aldehydes or ketones can be converted into ethylene group by using of strong bases like sodium ethoxide or sodium hydroxide. Then the reduction is called Wolff-Kishner reduction. Okay, these are the preparation methods of alkane. Thank you.